everyone. So as some of you requested, I am now creating a video about the third challenge that I had for you, converting 2D drawing into 3D model. So this is the third practice that you will do in our class, Creative Technologies 7. Okay, so for reference, I have this from numerate.com, this isometric drawing, 2D drawing, containing dimensions that later we will be using or following to create the 3D model. Okay, I hope you are ready. We will start. Again, this is the final product, and I will redraw this for you to follow step by step. Okay, let's create an empty file. Then again, make sure you are in part design. And then to create the first sketch, click here, create sketch. I know this is not new to you because we have used this already many times. Okay, create sketch. Then you will be asked to select from three base plane, the XY, the XZ, and the YZ. As for me, I choose XZ. Click this one and then okay. Now, the first thing that we will do is draw this one. But as you can observe, in this area, there is no specific dimension here because this opening will be created by the hole here. So please take note of that. This one, we will not draw this first because this will be created when we already create the hole, which is, this one is 80 millimeters in diameter. So we will follow the solid lines here, okay? And then follow the dimensions. Okay, let's start. Let's start with, so it will be easier for me to follow. Let's divide our screen. If you have this option too, you can do it. Okay, but this one, okay, the problem is I cannot see this one if I enlarge the first window. Okay, so I think that will be good. All right, I decided to change the strategy because it doesn't work, it doesn't fit. Okay, I would like this to be a constant reference as I draw the polyline here. So I transfer the drawing to my PowerPoint presentation, and so I can easily zoom in and zoom out for the dimension. So let's start. The first tool that we are going to use is this one. It's called Polyline. You will see the name if you hover your mouse on the tool, but this time it's not showing here, but here it will appear at the bottom left corner. It's Polyline in the sketch. You can also use M key. M, I think it's the shortcut, but I prefer using this. Okay, so let's start drawing here. Okay, so later we will be adjusting the measurements, of course, but as for me, I already tried to make the lines almost the same with what is in the drawing. So as you can see, when we draw the line, there are two sets of numbers there. We have 15.2 millimeter and 92 degrees Celsius. That refers to the length of your line and then the angle of your line. Okay, so as much as possible, I want it to be 90 degrees because it should be perpendicular considering or with reference to our drawing. And it is 25 millimeter. So let's make it even larger. Okay. It must be 25. Okay. It's 23 already. So let's have 22. The next is it must be 60, but including the 45-degree angle there. So let's just draw approximately 60. Later, we can add constraints and make our dimensions more accurate. Okay, so this one is 76. Let's have, okay, 62 will do. Then, okay, actually, I'm gonna teach you let's repeat. Okay, there's actually a mouse button. There are mouse buttons that we can press in order to move our drawing. Okay, again, let's have 25 first. 25, that's 23, 25.4. Then let's have 60. And then that is equivalent to 10, but later, let's check. 10 by 48 degrees. Then this one, there is no dimension there, but let's have an estimate yet. Let's have an estimate for now. Then this one is 180. Okay, if you reach this moment, if you cannot move there, you can press your uh, left key or left click. You can have left click and your scroll. Press your scroll and your left button, the left button of your mouse to get at the same time. So you can look at this. You can move your object. Okay, this one is 110 because 60, the total length here is 170. This one is 60. 170 minus 60, therefore this one is 110. So let's have approximately 110 at 0 degrees degree. 110. Okay, 112 will do. Then this one is 35. Let's have, okay, 35. Then again, let us not leave a hole here because later it will be automatically added when we add a hole. So this will be a straight line. And that is 170. Okay, you can press again your scroll and then your left button. So you can move your object. Okay. This one is 170. Okay, 169 will do. And then let's have 25. Okay. Then this one is 30. And this one is also 30. And let's close the object. Again, make sure you close the object. As you can see, there is a an X-like red indicator there with a dot at the center. That indicates that you are hitting the point. Okay? But now, as you can see, this doesn't look much like this because the measurements are not yet constrained. So let's start. As for me, I will start with this angle because this part is crucial. So let me add a constraint angle. Okay, this one. In our 2D drawing, it's actually 45 degrees. But as you can see, we did not hit the exact angle that we want to measure. So it's actually at the other side. It's not the 45 degree, but it's the 45 plus 90. And that is 135. So let's set it to 135. Okay, let's see if we are correct later. We will recheck. Then, as I mentioned here, make sure that you are doing this measurement, not the other one that will, okay, this one is 11, but that is not what we would like to add. It's not the measurement, okay? Remember that this one is 10 millimeters, and the direction of the dimension line is like this, not diagonal, but it must be, okay, so to be able to do that, let's change the okay, constraint vertical distance. Instead of just a common, just a normal dimension, you select the vertical distance. And that should be 10. Okay, so look, it's here. Actually, it's hidden, but that's it. Okay, now we can actually move also this to check if it's 45 degrees. Okay, that is 45 degrees. Again, kanina, 135 degrees siya kasi we measured at this area, not this one. But actually, we're supposed to measure this one. But by logic, we can say that if you already have a geometry class, if this is 45 degrees, then this side is 135. Okay, so I just deducted 180 by 45. Okay, or you can add 90 degrees plus 45. So we are done doing the measurements here, constraining the measurements here. Next is the measurement from here and here. It must be 60. It must be 60. Then this one and this one must be 25. Okay. And here, this one and this one must be, it must be 30. And okay, to make it cleaner, let's put the measurements here and then this one. Okay, next, this one is 25. All the measurements are seen in the 2D drawing, so you can always go back if you did it correctly or not. Okay, something is wrong here because this one is not 90 degrees. So what you're going to do is to click this one. This one is constrained single line to horizontal or vertical. it must be 90 degrees. So, okay, just click that angle to make sure it's 90 degrees. Okay, one problem done. This one and this one is wrong, so let's remove this one. This one should be 25 millimeters. Okay, I hit the wrong one. Let's zoom it out so we can see. Zoom in. Okay, 25. Okay, now it's correct. Okay, again, let's make it cleaner by putting the measurements right there. Then next is this one should be 30. This and then this one. Let's repeat. Make sure you hit the points, okay? That is 30. Also, this one and this one must also be 30. Okay, now we can see that it's already aligned. Now, from here to there, it must be 110 to make it 170. Oh, see, I entered the wrong measurements. It must be 110. Okay, then this one must be 100. No, it must be 35 millimeters. Then this one and this one must be again 170. Okay. Oh, I hit the undo button. I'm sorry for that. Let's repeat. This is 35. Okay, so we still have two DOFs or degrees of freedom. All right. Okay, this one and this one. Now it's time for, okay, this one. What should be the measurement of this one? If this is 35, then, and this one is 80, then 80 minus 35, that is 45. Okay, so let's measure this one and this one must be 45. Okay, that is already correct. Oh, see. Okay. All right, I think all the measurements are correct, but we can still move it. That's why we still have 2 degrees of freedom because it's not yet constrained to the plane. So let's have a measurement from here to here to make it constrained. And then this one. Okay, so it's fully constrained. It's already green. Now let's recheck the measurements before we close. Okay, this one is 25, 25, 25, 25, 30, 30. All in all, that is 80. Then this one is 60, 30, 30, and then we have 45 and 10, 110, and then 35. Okay, all good. Let's close the sketch. Okay. Now I want it to be larger so you would see. Okay, this one is the sketch that we have drawn. Now let's add a padding. Okay, now we will be asked to add a length. So where are we going to see the length? The length is this one. Okay, the top view, that is 66. So let's add 66 here. Okay, so this one is our drawing. Now it's time to add a hole. Okay, the hole here is the biggest hole is 80 in diameter, 80 millimeter in diameter. So let's add that. And it is at the bottom, not above, not on top of the drawing, but the bottom. Okay, let's turn our object or 3D model. Click the surface because we are going to draw the circle here. Add or create a sketch. Then, so naputol ang video. So I have to repeat. I did not notice. Okay, so let's go back to drawing the 80 millimeter circle in this area. You can draw anywhere for now, and later we can set the dimension to add constraint. So let's draw the circle. Just click, and then this one will appear. The box with numbers. Just add 80 millimeters. Okay, now let's go back to the file, to our reference file. This is 80 millimeters, and from the center of this circle, it is 60 millimeters from the edge. The center to the edge measures 60 millimeters. Oh, all right. So let's measure from the center to the edge. Okay, be careful because this one, you can click this one and this is the y-axis, and we don't intend to click that one because that is not the edge. So make sure you click the outer, this one, the circle. But if you draw it away from the y-axis, there's no worry. So in order for me to click this edge, I have to click this tool. This one is create external geometry. Okay, so I'll have to repeat clicking the dimension, click the center, then click the edge. It must be 60 millimeters. Okay, let me check again. This one is 60 millimeters. Okay, very good. Now, the distance from the center to the edge here, the horizontal edge, is 33 millimeters. Okay, so let's check first if we can, okay, we can select the edge, but before that, let's add external geometry. Okay, it's now purple. If it's purple, then it's working already. Then click the dimension, click the center, then here. We will know, or you will know, that you click the correct edge if the purple line, broken line, turns into gray. So right click and then set the dimension to 33 millimeters. Okay, so now you notice that the color of the object turned green. That means it is fully constrained. You can now close it. And then, since from our drawing, it's a circle hole, but it doesn't go through the entire surface. Observe that the circle is only right here, and the thickness is 18 millimeters. So let's add a hole, and that is 80 millimeters. And, oops, okay, I mistakenly clicked the OK vote button, and I'm not yet done setting up the hole. So if it happens to you, just double click again the hole, and then it must be 80 millimeters. And again, this 25 is wrong because the thickness is actually 18 millimeters. So let's replace this 25 by 8 with 18 millimeters. And also, make sure that your drill point is flat and not angled. Because as you noticed in our reference, this is flat and it is not angled. When we say angled, it looks like a screw, but this one is not the type, it's flat. So click the flat one and you will see, you can recheck.
Give me mommy.
Okay.
Thank you.
And also, as you notice, the whole cut type is countersink. That's why it's just like that. You can set it to none, so it becomes flat. Again, let's review the setup. It must be 80 millimeter in diameter. The depth must be 18 millimeters. And the whole cut type must be none. And it must also be, it must be flat. Okay, you can check before you click the OK button. You can check if it looks like this. And then click OK. Okay, now we are done with the first largest hole. Let's go back to the let's go back to our reference and see that there is a hole here that measures 35 millimeters in diameter, and the center of this hole is also the same with a large circle. So you can actually draw this one on top of the surface. Compared to the other circle, we have here the circle at the bottom. That's why we draw it at the surface at the bottom, on the surface at the bottom. But this time, you draw it on top of the surface. So what are we going to do is to click this surface because this is where the circle is found. Okay, sketch, create sketch, and then create a circle again. Okay, you can now click and then draw another circle that is 35 millimeters in diameter. Okay, again, there are other ways to do this, but let us do this first so that you will know how to do it, how to draw the sketch on the surface. Okay, again, there are other ways, but as for now, let's do this one so you can practice drawing the sketch on the different surface. Okay, again, the distance from the edge, if you try to look at that, the center and the edge, the horizontal edge is 33 millimeters. So let's go back to this one and let's check if we can select the edge. Again, we cannot select the edge. So we have to draw an external geometry at both sides. And then we can now set the dimension from the center to the edge. The horizontal edge is 33 millimeters. And from the center to the vertical edge, that is 60 millimeters. Now it's green, it's fully constrained. We can close it and then draw a hole. Okay, the hole must be 35 millimeters. And notice that it's actually a hole through the surface. And when you look at the original drawing, it doesn't go through. there's another circle here that goes through, but this one does not go through. It's 35 millimeters in diameter, but the thickness is only, look at this, the thickness is only 5 millimeters. So again, I clicked it in advance. It shouldn't be. So let's check the hole again. It's 35 millimeters. Just double click the hole here and check the depth must be 5 millimeters only. 35 millimeters in diameter. Again, it must be 5 millimeters in depth. Then again, the class is null. The hole cut type is also none, and it must be flat. Okay. Notice that it's already like this. So there's a hole, but it doesn't go through. That means hindi siya nabutas talaga papunta sa pinakadulo. So it's only 5 millimeter in depth. Okay. There's an existing sketch because I repeated this already. But there's no need for this already. You can draw another circle. Okay. Let's click OK first. Must be 5. Okay, be careful as you scroll, just like what happened a while ago. When you scroll your mouse here, it will change the value of your diameter and depth. So always review it, then click OK. Again, there's a circle sketch here because I already repeated this one because I thought it's recording, but it's not. So I'll just remove this one because there's no need for that. You can actually just click this one and create another hole. That's it. The hole now, the smallest hole here is only 20 millimeters in diameter. That's why it's smaller compared to the 35 millimeter diameter and this 80 millimeter hole. So, as you can observe, it goes through the object. Ibig sabihin, nabutas na siya talaga, diretso. And that is, if this is 35 minus 5 minus 18, you will get the thickness of that. But it's no longer necessary because all you have to do is set it to through all. It should pass through the entire object. Okay, so this hole is 6 millimeters by default, but it must be 20 millimeters according to the drawing. Okay, that's what I mean. If you set it to 25 millimeters, of course, it will pass through the entire object because the thickness of this object is only 30, 35, and there's already an existing hole, the bigger hole at the bottom. So it's already good. But to make sure that you have it in your mind that it's through all, you can actually click instead of dimension, choose through all, which means the hole should pass through the object. Okay, now we are done with the 3 holes. Okay, so this is already correct. This smaller hole is 20 millimeters in diameter. This bigger hole is 35 millimeters in diameter. And this largest hole is 80 millimeters in diameter. And as you try to look at that, it created a rectangle hole or hole in this side or surface because the circle 80 millimeter in diameter is too large for this surface. So it cut this side of the object. Now let's proceed to the last part, the smallest hole. And this one is actually an arc. How did I know? Because there is an R25 here. R means radius. Therefore, this line is actually curved because it has a radius measurement. So let's proceed first to this circle. This one is 16 millimeters in diameter. Okay, let's draw. So since it's found here, click the surface, but let's click this OK first to set the hole. Click this one, and make sure it's the only surface that is highlighted. If you click other parts, it will all turn green, and that is not correct. So just this one should turn green because this one is the surface where we are going to draw our sketch. Click Create Sketch, and then draw the circle here, which is 16 millimeters in diameter. Let's review. This one is 16. Now let's check the distance from this edge to the center of the circle is 15 millimeters. So let's try first if the sides or the edges are clickable. Okay, the edges are not clickable, so let's create an external geometry. Then click dimension, click the center, and then the external geometry. Again, in order for you to know that the correct edge is clicked, if the purple broken line turns gray. Okay, so that is 15 millimeters according to the reference. Now, from the center to there, we can see that this line it goes to 33 millimeters. So from the center of this little circle, small circle, to the edge is 33 millimeters. Now let's measure. This one is 33 millimeters. Okay, now you can see that it turned green again. Okay. Actually, it doesn't matter if you set the circle to 16 millimeters because later when you create the hole, you will still set it again to the correct size. But the most important thing here is that the distance from the center to the edge should be correct. The distance from the center to the other edge must be correct. Now, click close and then click hole. Okay, see, the hole by default is 6 millimeters in diameter, but we need 16 millimeters. And that's it. I click again the OK. Let's go back because we're not done yet. Okay, now notice that it's 25 millimeter good because that's the exact thickness or depth of this side of the object. And make sure it's dimension in 25 millimeters because here, try to look at that. This is the hole. That is the hole projected here. The hole is 25 millimeters in depth. Do not choose through all because if you choose through all, this hole will go through this part of the object because you said through all, so it's gonna have a hole as well. But in the 2D technical drawing, there is no hole in this side, so it must only be 25 millimeters. Okay, so that is already correct. Just make sure it's not angled but it's flat and the hole cut type is none. Now we can click OK. Okay, let's review if we did it correctly. All right. Okay, the hole is okay. That one is the hole. Now, okay, this one is already the object. Now we still have a missing part. Okay. Okay, let's review. Now, the missing part is in this area because as you noticed in the drawing, there's a broken line here. Again, I told you a while ago that there's a curve here because there's a note here or part of the dimension. There's R25 that is radius 25 millimeters. So this line is actually an arc. So we have to draw an arc here. Why is it straight here? Because when at side view, it will really be straight. But if you turn it this sideways, this at this side, it will be curved. But R25, there's no need for that because there's already a measurement here, which means it's a curve. It's an arc because it has a radius. Now, since we are going to draw here the arc, just click the surface. Then again, click create sketch. Okay, so this one, to make sure, this one is the bottom, right? Let's recheck because I got confused. Okay, this one. Okay, make sure you are in this side. Okay, again, let's click this one and then create. Okay, this area. Now, the arc there is, the measurement of the arc is 25. And as you notice, the center, this one is a center line. If you can recall, our first lesson in technical drawing is the different types of lines. And this one is actually a center line. Okay, notice that this one is a center line. That means that from this edge to the center of the arc, an arc has a center, by the way, always remember that this arc has a center and the center to the edge is 40. And from the center to this edge as well is 15 millimeters. Let's see later. Let's check first. It must be 40. Remember that, 40. Okay, let's draw the arc first. This one is the tool for the arc. You can have other options, but the best option in this situation is create arc by the center because we have to constrain the center from this edge to this, and that should be 40 millimeters based on our drawing. Okay, click anywhere and then set the radius of this arc to 25. Okay, then again, this one we start at the center. And remember, in an arc, we set the 3 points. And we already set the first point. Now, we can set the second point. Since what we are trying to do here is half circle, then this must be 90 degrees Celsius. You can write 90, okay? And then, if you have already discussed this in your mathematics class, specifically geometry, if we are forming a straight line, the angle for that is 180 degrees. So, write 180 degrees. Okay, so now our arc is already here. It's already in with the correct measurement, R25 millimeters, and this one is already straight. Okay, this time, let's make sure that from the center to here, it must be 40. Again, where did I get that? This one is the measurement from this edge to the center, that is 40. Okay, now let's click the center and the edge. Okay, again, the edge is not clickable, so let's create an external geometry by clicking this tool and then make sure it turned purple. Now, since that is already purple, and later we will also be using this external side, so let's prepare and click add external geometry there. All right, from the center to here, as I have mentioned repeatedly, that is 40 millimeters. Okay, notice that it turned something like it tilted, so it's not good because the center to there is correct, but this one, which should be aligned to the center, must also be 40 millimeters. So let's constrain that as well. Click that point, and then external diameter, external edge, I mean, that must also be 40 millimeters. Okay, that's good because as you can see, the center point and the other points are already aligned. It's not yet green, but it's okay. We still have to constrain that because as you can see, if we move that, it is still movable because we have not set the center and this edge. Okay, now the center, it must be at the center of this object. So this object is actually 60 millimeters, 66 millimeters. Where did I get that? This one is 66 millimeters, and it is at the center of 66. The same with this one. It must be this one. It's actually the arc, this rectangle. Okay, it looks like rectangle from the top, but from the side, it's an arc because of the radius 25. So look at that. The center of that is actually 33. Okay, so we're done with the 40. Now let's measure from the center to the side. It must be 33. Okay, now it turned green, which means it's fully constrained. Now, we cannot create here a hole or a pocket if the object is not closed. So we have to close this object. And how do we do that? We need a vertical line. So let's click the line tool and then make sure you click the point because if you do not, then it will still be an open wire or an open object. Okay, how do we know that we are at the right point? Make sure you see that red X with a red dot at the center. That means you are pointing at the right point. Okay, then click. Now let's see. As far as I can see, it's already closed, but we'll know later if it's closed if the arc is formed. If it's not, an error will appear that the wire is closed. Okay, let's try. Okay, now, okay, for you to see clearly, okay, this is the one that we have drawn. Okay, actually, it's like that. But from the top view, of course, it's just rectangle. And in the side view, it's a rectangle. But in this side, which unfortunately not shown in the technical drawing that we have as a guide, it's actually curved. But because there's already a note that there is a radius, then automatically, if you can see that, you will conclude that it's an arc. Okay, now we can create a pocket, not a hole, but a pocket. Okay, now the pocket here is just like this because it's 5 millimeters. And as you look at that, this one is the entire shape that we are following, and that is 30, not 5. So this is not enough. We change the length to 30 millimeters. Okay, let us see if it worked. Okay, then. Okay, now it worked. Let us see. Okay, so this one is the arc. We have a circle here, we have a small circle that goes through all, then an arc that is 30 millimeters in length and 25 millimeters in diameter. Okay, now our challenge number 3 or exercise number 3 is done. We have converted this 2D drawing to 3D drawing. And here it is. Okay, I hope you get all the steps. If there are parts that you were not able to follow, you can send a message, send a question to me. And just the purpose of this is for you to apply what you have learned before, exercise, and also to start analyzing 2D drawing and converting it to 3D model. God bless.